Hi grade 11s, today we're going to look at the angle between two lines. Before we do that, let's remind ourselves about what the inclination of the line is. The inclination of a line is the angle that the line makes with the positive direction of the x-axis. However, if we drew any horizontal line, a line parallel to the x-axis in other words, then you will notice that that angle there would be equal to this angle there. So whether you're looking at it from the x-axis, the angle the line makes with the x-axis, or any other horizontal line, then this angle here is still called the angle of inclination. Just remind also, we know it can be acute or it can be obtuse, and when it's obtuse we use this formula and then we would add 180 to it when we work out theta. So to determine the angle between two lines, we draw a horizontal line through the point of intersection of the two lines, and we're going to use the inclination of both the lines to determine our angle. Let's see how that works. It says here, determine the size of alpha in each of the following diagrams. In our first diagram, we have these two lines, y equal to minus 2x plus 3, and the line y equal to x plus 1. And this is alpha. Alpha is the angle between these two lines. So we're going to follow these guidelines. Draw a horizontal line through the point of intersection of the two lines. So I'm going to draw a horizontal line. Here's my horizontal line. So here I've drawn the horizontal line through the points where the two lines intersect each other. And this is I've called this angle of inclination, I call theta 1, and the angle of inclination, the other line is called theta 2. Remember, it's the angle that the line makes with the horizontal. So there's the inclination of the line y equal to x plus 1, and y2 is the inclination of the line y equal to minus 2x plus 3. So to work out these two angles, we know we need the gradient of the lines. So theta 1, we're looking at this line y equal to x plus 1, and we know then, because the line is written in this format, that the gradient is the coefficient of x, which is 1 in this case. So to work out this inclination here, I use the gradient. So tan of theta 1 is equal to 1. Use my calculator, say arctan theta, in other words, inverse of tan on the calculator, and you get an angle of 45 degrees. So theta 1 is 45 degrees. The second line here, y equal to minus 2x plus 3. To work out theta 2, I need the gradient of that line. And here I can read off the gradient. Gradient is negative 2. So therefore, tan of theta 2 is equal to minus 2. Employ my calculator, second function tan, and you add 180 to get the positive angle. So theta 2 is 116,57 degrees. Therefore, alpha is going to be theta 2 minus theta 1. Okay, there should be 1 over here. Just change that, theta 2 to theta 1. So theta 2, which is 116,57, minus 45 will give me alpha, and alpha is therefore 71,57 degrees. Let's look at our next example. In our next example, we have these two lines here, and we must work out alpha. So we're going to do what our guidelines said. We're going to draw a horizontal line through the point of intersection of the two lines. So here's my horizontal line. Okay, here I've drawn my horizontal through the point of intersection of the two lines. Now it looks quite busy, but let's just bear with me here. The inclination of this green line here is the angle that this line makes with the horizontal. So this is theta 1, I've called it. And the inclination of this black line here is the angle that this line makes with the horizontal. That's theta 2. And we're going to work out the value of theta 1 and theta 2, and that's going to help us work out this angle here, alpha. In other words, DPA is alpha that we want to work out. So in order to work out the angles of inclination, or the inclination of the line, we need to work out the gradient of each line. So if I'm working with line AB, then I'm going to have to work out the gradient of AB first. So it's the change in the y over the change in x. So it's minus 1, minus 1. Change in the y, over the change in x. So it's x value is 5 minus the x value there is 1. So it's 5 minus 1. So on top we've got negative 2 and 5 minus 1 is 4. You work that out, you got a gradient of minus half. So the gradient of this line AB is minus a half. So we can use that gradient and we can work out what theta 2 is. Remember, theta 2 is the angle of inclination, or the inclination of this line here, AB. Employ your calculator and you say second function tan, add 180, because when we have a negative gradient we have to add 180 to get the positive angle of 153,43. So that's theta 2. Now we're going to work out theta 1. In order to work out theta 1, we need to work out the gradient of the line CD. Gradient of CD is the change in the y values over the corresponding change in the x values. So if I say minus 2, if I start with the y value of C, then it's minus 2, minus 2. Over 3, because we start with the y value of C, we must start with the x value of C. 3 minus 2. So minus 2, that's the change in the two y values over the change in the x values. So this gives you negative 4 over 1, which is negative 4. So to find the inclination of this line CD, I use the fact that the tan of that angle is equal to minus 4. Employ my calculator, and I will have to say second function tan, that will result as a negative angle on your display. So you add 180 to get the positive obtuse angle here. So now we have these two angles. Theta 1 is 104,4 and theta 2 is 153,43 degrees. So this angle here, BPD, if I subtract theta 2 minus theta 1, in other words 153,43 minus 104,04, and I get an answer of 43,39. So this angle here, BPD, is 43,39. Now why did I work that out? Because this line AB is a straight line, and this angle plus alpha is 180. So to find alpha, I just need to say 180 minus this BPD. So alpha is therefore 180 degrees minus 49,39 degrees, and that gives you an answer of 130,61 degrees. Let's look at this last example here. Here we have this angle alpha, and we want to determine the size of this angle. Notice it is the angle between this line 2y minus 3x equal to 4 and the y-axis. So we're going to follow our guidelines. We're going to draw a horizontal line to the point where these two lines which make up that angle intersect each other. So there's my horizontal line. There's my horizontal line drawn through the point of intersection which makes up this angle alpha. Note that that horizontal line, we know it is parallel to the x-axis, so we know that this angle here is 90 degrees. This angle is 90, and I'm going to call this angle above that the inclination of that line 2y minus 3x equal to 4. I'm going to call that alpha. So let's call this part here alpha, inclination of the line. So let's call that alpha. This angle here is alpha. So we know to work out the inclination of this line 2y minus 3x equal to 4, we need to determine the gradient. So let's write it in gradient y-intercept form. In other words, make y the subject. Add 3x on both sides, get 3x plus 4. That's how you get rid of the minus 3x. You add 3x on both sides. Now you divide both sides by 2. And you get y, 3 over 2x, and 4 divided by 2 is 2. The reason for us writing it like this, so we can easily see what the gradient is. The coefficient of x when y is the subject. So my gradient is 3 over 2. Why do I want the gradient? Because to work out the inclination, I need the gradient, and I use tan theta is equal to 3 over 2. Employ your calculator. So second function tan of 3 over 2, and you will get 56,31. Now that is the inclination of this line. So theta, which is 56,31, plus the 90 degrees here, will give me alpha, which is the angle between the line 2y minus 3x equal to 4 and the y-axis. So alpha is 146,31.